We are talking about the quadratic formula, and we want to solve quadratic equations using the quadratic formula. And we want to analyze the discriminant to determine the number and type of solutions. The definition of the quadratic formula. The solution of a quadratic equation of the form ax squared plus bx plus c is equal to 0 are given by the following formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. The discriminant is the part under the radical, is b squared minus 4ac. The discriminant is the value of number under the radical. The discriminant will identify the number of solutions and type of solutions. So if we look back at the equation in standard form, we have ax squared plus bx plus c. Usually we say that's equal to y, but specifically in this case, we're substituting in 0 for y. So we know that we're going to have, instead of an ordered pair x, y, we know that we're going to have some x value, and we're going to know that the y value is going to be 0. And we'll look at a couple examples. So we have b squared minus 4ac is greater than 0. So basically this just says what's under the radical is greater than 0. And in that case, if it's greater than 0, that means positive. So if we have a positive number under the radical or in the discriminant, that's going to be 2 real solutions. So here we have negative 2, 0 and 4, 0. And we'll look at what that looks like algebraically. So we have x equals 2 plus or minus the square root of 36 divided by 2. So we see that we have a positive value under the radical, and we know that we know the perfect square of 36. So the square root of 36 is 6. So we get x equals 2 plus or minus 6 divided by 2. And in this case, we know that 2 divides into both 2 and 6 because they're both even. So we can rewrite this as x equals 1 plus or minus 3. And that's where the plus or minus comes in. So actually evaluate this twice. So then we get x equals 1 minus 3 and x equals 1 plus 3. So in this case, we get x equals negative 2, and here we get x equals 4. And then we have to remember that these are x coordinates, and we understand that when we're using the quadratic formula, our y value has to be 0. So we get the ordered pair negative 2, 0 and 4, 0. So we have 2 separate solutions when we have a positive value under the radical. And that's what we have shown here. Then we have one real solution if b minus 4ac is equal to 0. So if our radical is 0, then we have one solution. And actually we have a double root here, or multiplicity of 2, because it just touches the graph there. And we can look at what that would look like algebraically. So here we have x equals 8 plus or minus the square root of 0. And in this case, we know that the square root of 0 is just 0. So we can rewrite this as x equals 8 plus or minus 0 divided by 2. We know that 2 divides into 8, and 0 divided by 2 is still 0. So we can get x equals 4 plus or minus 0. And then we can rewrite that as plus 0 and minus 0. So x equals 4 plus 0, and x equals 4 minus 0. So we get x equals 4 and x equals 4. So in this case, we have a multiplicity of 2 or a double root, and our solution for this one is going to be 4, 0. So with a positive under the radical, 2 solutions, 0 under the radical, only 1 solution. And we have one more to look at. And that is when the discriminant b squared minus 4ac is less than 0. That means that we have a negative number under the radical. So if we have a negative number under the radical, we don't have any zeros. We don't have any zeros. The graph never crosses or never touches the x-axis. So here with 0, we see that it touches just once. We have a multiplicity of 2 or a double root there. Here we have one real solution, so we have a multiplicity of 1 because it crosses twice. Here we have 2 imaginary solutions or no real solution, no x-intercept. And we'll take a look at what that looks like. So here we have 4 plus or minus the square root of negative 4 over 2. And we know that we can break this down. We know that the square root of 4, we know that's going to be 2. And the negative value, the square root of negative 1, that's going to be equal to I. So we can rewrite this. So we can say x equals 4 plus or minus the square root of 4 is 2. And the square root of negative 1 is I. So we can rewrite that. 2 divides into 4 and also divides. So we get x equals 2 plus or minus I. And so we get 2 solutions here. We get x equals 2 minus I and x equals 2 plus I. And in that case, we have our zeros of 2 minus I, comma 0, and 2 plus I, comma 0. So if it's negative, we have 2 imaginary solutions. We have the I there. If the discriminant is 0, we have 1 solution. If the discriminant is positive, we're going to have 2 solutions.